So the next bit that we need to recall again from what you've seen before at school is linear equations in two unknowns. So again, what is this exactly? Well, here's an example. That's perhaps the best way to sort of recall what that means. So the example question here is, suppose you have two equations. First one is 2x plus 3y equals 18. And the second one is 3x minus 4y equals minus 7. Well, these are two equations in two unknowns, because the unknowns are obviously the x and the y. And the question, of course, is what are the x and the y that actually solve these two equations simultaneously? So you might know, or you might want to read in your book, that there are actually two related ways of solving this this problem. One is by substitution, the other one is called by elimination. So in the book you'll find actually both these methods applied for this particular example. So what we shall do here is actually look at the elimination method, where actually we have two choices. We can either eliminate x or we can eliminate y. So I'm going to do this actually for you on paper, to follow the route of eliminating x and then solving for y. So this is how it goes. So let's look at the problem again. So the problem on paper is going to be 2 times x plus 3 times y equals 18. That's the first linear equation. So it's linear because all these parameters, all these variables, the x and the y, they just appear here in a linear fashion. There's no squares or whatever of x. And the second equation is 3x minus 4y equals minus 7. So these are two equations in x and y, and we need to find what values of x and y are going to solve those two equations simultaneously. And we are going to do this, we're going to solve this by eliminating x. So what does that mean? You're going to say, well, actually we want to get rid somehow of this x. How can we get rid of this x? Well, the first step is try to make the coefficient in front of the x the same in these two equations. So here I have a 2 in front of the x, here I have a 3 in front of the x. So what's more natural than just multiplying the first equation by 3? So what does it mean? Well, multiply the first term here by 3 gives us 6x. I also have to multiply the rest, of course, by the same 3. So we get 9 times y equals 3 times 18. So if you think of it, 3 times 18, I hope, is 54. So this first equation was multiplied by 3. So I want the 6x also to appear in the second equation. So what do we need to do? Well, I have to multiply the second equation actually by 2 to make sure that's going to happen. So let's see how that works. So if I multiply the second equation, we get 6x minus 8y. That's multiplying the left hand side by 2. Then I also have to multiply the right hand side by 2 to make sure it remains the same equation. It gives us minus 14. 2 times minus 7 is minus 14. So now we can proceed by noting that, well, there's a 6x over here, there's a 6x over there as well. What we can do is actually subtract these two equations. So subtract them term by term. So the x term, the 6x minus the 6x, that's 0, right? That's why this is called elimination. We have eliminated the x by this process. We also have to subtract the y term. So 9y minus 8y. So I have to subtract a negative number. So you remember, of course, subtracting a negative is adding the positive. So 9 minus 8y is going to be plus 17y. And similarly over here, with 54 minus 14, that's the same as 54 plus 14, that's going to be 68. Is this helpful? Yeah, it is, of course, because what do we have? We now know that 17y equals 68. And if you look a bit deeper into this, you will notice that we can solve this easily, because this is solved by y equals 4. 4 times 17, you'll easily convince yourself, is equal to 68. So y equals 4 solves this equation. So now we know y. Well, we are asked to actually know both the x and the y. So y is solved. We still need the x. So how can we find the x? Well, we still have these two original equations. So let's now use the fact that we know that y should be equal to 4 by plugging that in and then figuring out what x should be. So let's do that. 2 times x plus 3 times y. Well, y should be equal to 4. We know that. So 3 times 4 equals 18. Or in other words, 2 times x plus 12 equals 18. Or in other words, 2 times x equals 6. So x equals 3. So the solution to this problem of solving these two equations in two unknown, we first found what y was by this elimination method. Then we plugged it in the first equation here to get x equals 3. So the solution is x equals 3, y equals 4. So could we also have used the second equation? Well, yes, hopefully we can actually use that as a check. So let's see whether it checks if you plug in x equals 3, y equals 4 in the second equation. Hopefully that's going to hold. So x equals 3, so 3 times 3, well, that's going to be 9, minus 4 times 4, 9 minus 16, and indeed that's minus 7. So that's a good check whether you didn't make any calculational mistake. So the solution to this problem is x equals 3, y equals 4. Or we might actually write this sometimes as x comma y equals 3 comma 4. That has the same information in. Okay, so let's go back to the slide now. So here we are on the slide again. So this is what we did. So on the slide, I did the same thing. So I multiply the first equation by 3, the second equation by 2. Why did I do this? Well, then we get the 6x in both linear equations, and that allows us basically to subtract those two, which is what's happening over here. So what remains is this 17y equals 68, and then I told you that that is solved by y equals 4. Then we're almost done, because once we know that y equals 4, we can easily look back in either the first or the second linear equation to figure out what the x is, and we figured out indeed that x equals 3. So that was the linear equations in two unknowns, and you're going to practice those, of course, in your tutorial. And the final thing that remains for today is looking at functions, domain, and range.